One of the most important topics that's going to come up on the AP exam is limiting reactants, and having a very firm understanding of what a limiting reactant is versus an excess reactant. A limiting reactant is a reactant that is completely used up at the end of a chemical reaction, while the excess reactant is the reactant that there happens to be some left over at the end of the reaction. So to help you out with this particulate level diagram, I actually inserted a balanced chemical equation. At the top here, we have N2 reacting with H2 to form NH3, which is ammonia. For every 1 mole of N2 that reacts, it requires 3 moles of H2 to also react to then form 2 moles of NH3. And here's the example that we have here in the particulate level diagram. We have 3 moles of nitrogen before the reaction, and we have 6 moles of hydrogen before the reaction as well. Well, really, I should have 3 times as many moles of hydrogen as I do nitrogen. And if you can look before the reaction here, I only have 2 times as much. So I don't really have enough to satisfy that ratio of this particular equation. The other way to look at it is I only need 1/3 as much N2 as I do H2, and I have 1/2 as much, which is clearly bigger. So at the end of this reaction, it makes sense that I should have some nitrogen left over because it is the excess reactant, whereas the hydrogen is completely used up. And you can see here I have some N2 floating around because it hasn't been entirely consumed. For this practice example, we have the synthesis of water from hydrogen and oxygen, and it's used to produce electricity in a hydrogen fuel cell. Suppose a fuel cell contains 150 grams of H2 and 1,500 grams of O2. 3 questions that we're going to answer. This is a multi-step problem. How many grams of water can potentially form? How much of the excess reactant would remain after the reaction? And what would be the percent yield if only 800 grams of water forms? I'm going to give you about 5 minutes to work that out. So at this time, I would pause the video, then we're going to go over the solution together. Okay. First thing is I wrote out the balanced chemical equation. So I have 2H2 plus 1O2 gives me 2H2O. I also took my starting quantities of hydrogen and oxygen and I immediately converted them into moles. According to this reaction, I should have twice as much hydrogen as I do oxygen. But you can see here, I don't quite have twice as much hydrogen as I do oxygen. I actually have much less than that. So that's telling me that this is my limiting reactant. This is my excess reactant. And I want you to look at the stoichiometry of this balanced chemical equation. For every 2 moles of H2 that I consume, I produce 2 moles of H2O. That's a 1-to-1 ratio. So if I put 74 moles of H2 into this reaction, I should get 74 moles of hydrogen back out. Using the molar mass of water, 18.02 grams per mole, I can then convert that into the number of grams of water that I would expect, which would be 1,300 grams. The next part is I'm trying to figure out, well, how much oxygen was consumed and how much is going to be left over. Oxygen is the excess reactant. I know that half as much O2 as what I start with my H2 is going to be consumed. And I can also make that a formal conversion factor that for every 2 moles of H2 that is consumed, I'm also consuming 1 mole of O2. That allows me to make the prediction that 37 moles of O2 should actually be used, which makes sense because I started with 47 and I know it's in excess. So I'm using less than what I have. That gives me 10 moles of O2 that are left over, and then multiplying by the molar mass of oxygen, which is 32 grams per mole, 320 grams of O2 should be left over. The final part of this problem is to make a prediction. What is the percent yield of this particular reaction? Now, if I go back to the original problem, 800 grams of water was actually formed. So therefore, that becomes my actual quantity in my percent yield calculation. Going back to what we previously calculated in the other part of this problem, we found that we were generating 74 moles of water, which was 1,300 grams of water. That is a theoretical quantity. That is, in a perfect world, I do this without any loss of product. I do this without any error. That's the amount that I should have gotten. By making a ratio out of that, my actual yield divided by my theoretical yield, my final percent yield comes out to be 62%.